Hello everyone, and welcome back to the EnvisionPlay tutorial series. In the previous tutorials, we learned how to create scenes, add objects, work with materials, configure physics, and position cameras. Today we're going to look at one of the most powerful features in EnvisionPlay, the behavior map. The behavior map allows us to create gameplay without writing code. Instead of programming, we connect behavior nodes together to tell our objects what they should do. These nodes can handle things like player input, movement, collisions, animations, physics, UI interactions, camera control, game state, and much more. Now don't worry if that sounds like a lot. In this video, we're going to keep things simple. We're going to build a small interaction where clicking a box makes it disappear and causes a sphere to change color. Along the way, you'll learn the basic concepts behind the behavior map system. Let's jump in. Let's start by creating a brand new scene. Over on the toolbar, click the New Scene button. A blank scene will be created. Before we do anything else, let's position the camera. Use the camera controls from the previous tutorial to move around the scene. Rotate the camera with the right mouse button, zoom with the mouse wheel, and pan using the middle mouse button. I'm going to position my camera here so I have a clear view of the center of the scene. Adding some objects. Next, let's add two objects, a box and a sphere. Spread them out a little so they're easy to see. These two objects are going to help us demonstrate how objects can communicate with each other using behavior maps. Opening the behavior editor. Let's begin with the box. Hold left shift and click on the box to select it. Over in the properties panel, find the behavior map section, then click Edit Behavior. The behavior editor will open, and you'll immediately notice that there's already one node here, the Initialize node. Every object automatically starts with this node. You can think of it as the entry point for the object's behavior. Whenever the object is loaded into a scene, the Initialize node sends a start signal. That start signal can then activate other nodes connected to it. Almost every behavior map begins here. Building our first behavior. For this example, we're going to add 4 nodes: a state machine, a mouse picker, a send, signal node, and a destroy node. Go ahead and add those to the graph. Once they're added, drag them around and arrange them neatly. Keeping your graph organized makes larger behaviors much easier to understand later. Now let's connect some nodes together. Connect the start output on the Initialize node to input 1 on the state machine. As soon as the scene starts, the state machine will enter its first state. Next, connect output 1 on the state machine to enable on the mouse picker. At this point, the mouse picker is now active and waiting for input. Before we continue, let's quickly talk about the state machine. A state machine allows us to control what should happen at different stages of an object's behavior. Think of it like a traffic controller. Only one state is active at a time. When a state becomes active, its matching output becomes true. In our example, we only need 2 states. The first state waits for the player to click the box. The second state activates after the box has been clicked. That's all we need for this simple setup. Now let's tell the state machine when to switch states. Connect the yes output on the mouse picker to input 2 on the state machine. Select the mouse picker node. In the properties panel, change the mouse button setting to left. Everything else can stay at its default value. Now what's happening is very simple. The mouse picker is waiting for the player to click the box with the left mouse button. When that happens, state 2 becomes active, making the box disappear. Now let's define what happens when state 2 becomes active. Connect output 2 on the state machine to enable on the send signal node. Then connect output 2 to enable on the destroy node as well. Notice that one output can drive multiple nodes at the same time. Select the send signal node. In the event name field, enter my signal. Perfect. Now, when state 2 becomes active, 2 things will happen. First, a signal called my signal will be sent. Second, the box will be destroyed. Let's test it. Click play. Now, click on the box, and there we go. The box disappears. That's exactly what we wanted. Now let's make the sphere react to that signal. Switching the sphere to listen. Stop the simulation and select the sphere. Open its behavior map. Just like before, we start with a single Initialize node. For this object, we're only going to need 2 nodes. Receive signal and set color. Add both nodes to the graph. Connect Initialize Start to enable on the Receive Signal node. Now select the Receive Signal node. For the event name, enter my signal. This tells the sphere to listen for the signal being sent by the box. Next, connect the output of received signal to enable on Set Color. Select the Set Color node. Under Base Color, enable the checkbox. Then choose a green color. That's all we need. Now the sphere is waiting for that signal. As soon as it receives it, it will change its color. Let's test it. Press play. Click the box. Watch what happens. The box disappears, and the sphere turns green. Perfect. Conclusion. And just like that, you've created your first gameplay interaction using the behavior map. The box and sphere are completely separate objects, but they're communicating through signals. This is one of the core ideas behind the behavior map system. In this tutorial, we've only used a handful of nodes, but EnvisionPlay includes many more for movement, animation, physics, UI, camera control, saving data, game state management, and much more. We'll explore many of those in future tutorials. For now, make sure to save your scene. Thanks for watching, and happy creating.